For over a century, astronomers watched Betelgeuse breathe. Its brightness would rise, dim, then rise again, on a rhythm nobody could explain. In 2026, three different telescopes, Hubble, Gemini North, and the VLT in Chile, all pointed to the same answer. Betelgeuse isn't alone. There's a second star, orbiting so close it's plowing straight through the giant's outer atmosphere. It already has a name, Siwarha. So how do you hide a whole star right next to the brightest star in the sky? Okay, so let's actually set the scene, because the scale here is what makes this whole mystery so strange in the first place. Betelgeuse sits about 650 light-years away, in the shoulder of Orion. It's the reddish-orange star you've probably pointed out without even knowing its name. And it is enormous. We're talking a red supergiant so big that more than 400 million suns could fit inside it. It's near the end of its life, and someday, we don't know exactly when, could be next year, could be 100,000 years from now, it's going to go supernova. Because it's so close and so big, Betelgeuse is one of the only stars where we can actually watch its surface change over time. It's basically the one giant star we get to study up close. Which is exactly why this brightness mystery bugged astronomers for so long. They had a front row seat, and they still couldn't explain what they were seeing. Here's the thing. Betelgeuse doesn't just have one brightness cycle, it has two stacked on top of each other. There's a shorter one, a few hundred days, tied to the star physically swelling and shrinking, which is pretty normal for a star this size. But there's also a longer, slower cycle, roughly 2,000 days, called the long secondary period. And for decades, nobody could explain that one with pulsation alone. It just didn't fit. And then in 2019 and 2020, Betelgeuse did something dramatic. It dimmed so much, so fast, that some astronomers genuinely wondered if it was about to explode. Turned out to be a dust cloud it kicked off itself. But that whole event put Betelgeuse under a microscope, and once people started looking that closely, the long secondary period mystery got impossible to ignore. Astronomers had actually been logging Betelgeuse's brightness for well over a century. Groups like the American Association of Variable Star Observers have systematic records going back generations. And that long secondary period had been sitting there, unexplained, this entire time. That would be Steve Howell over at NASA Ames. Earlier modeling work had predicted the companion, if it existed, should be easiest to catch at what's called its maximum elongation, the point in its orbit where it looks farthest away from Betelgeuse as seen from Earth, giving instruments the best shot at separating one point of light from the other. Back in 2024, working off that prediction, he pointed the Allo-Pk speckle imager on the Gemini North telescope in Hawaii right at that spot. And he got something, a faint signal exactly where the math said it should be. But here's the honest part, because this is where good science gets careful instead of triumphant. That detection was only at what's called 1.5 sigma. Sigma is basically a measure of how sure are we this isn't just noise or a fluke. Scientists generally want 5 sigma before they'll call something confirmed. So 1.5 was intriguing, but nowhere near enough to say, found it. Even so, Howell's hint was solid enough that in September 2025, the International Astronomical Union officially named the hypothetical companion Siwarha. So at this point in the story, the star had a name before anyone had solid proof it was really there. That's not as backwards as it sounds. It happens with predicted objects all the time. The name was ready, the confirmation still had to catch up. Hubble did. In January 2026, a team led by Andrea Dupree at the Center for Astrophysics, Harvard and Smithsonian, published new Hubble data, and this time, they weren't looking for the companion directly, they were looking for its wake. Picture a boat moving through water. It doesn't matter if you can see the boat itself, you can see the trail it leaves behind. That's basically what Dupree's team found, a dense stream of gas in Betelgeuse's outer atmosphere, shaped exactly like what you'd expect if something was plowing through it. The companion, they calculated, sits only about 2.3 times Betelgeuse's radius out, which sounds like a lot until you remember Betelgeuse itself is hundreds of times wider than our Sun. That companion is essentially skimming through the giant's outer skin. July 28, 2026. This is the moment the whole story clicks into place. A team using the VLT, the Very Large Telescope in Chile, and an instrument called Sphere, which is built specifically for spotting faint things next to overwhelmingly bright things, captured the clearest direct image yet of what's almost certainly Betelgeuse b. That's a genuinely hard technical problem to solve. It's a bit like trying to photograph a firefly sitting right next to a lighthouse. Sphere normally exists to spot faint exoplanets drowned out by their host star's glare, so pointing it at Betelgeuse was putting it to exactly the kind of task it was built for. And this time, the confidence level was 6.1 sigma, above that 5 sigma line scientists like to see. Confirmed independently by two separate methods of processing the data. That's the image that finally puts a face to the name astronomers had already picked out. And honestly, the naming is a nice little detail. Betelgeuse comes from Arabic, meaning roughly the hand of the giant. Siwarha comes from the Arabic word for bracelet, so you've got a giant hand and a small bright bracelet circling its wrist. That's not an accident, that's the actual reasoning behind the name. Not quite, and this is worth sitting with for a second because it's honestly more interesting than a clean, mystery-solved bow on top. Even the lead author on the VLT paper, Miguel Montargez, is still calling it a candidate rather than a fully closed case. There's a confirmation observation planned for late 2027 at the companion's next predicted elongation point that should settle it for good. But here's why that caution doesn't take anything away from how big this already is. You've now got three completely independent lines of evidence: Howell's early speckle imaging, Dupree's Hubble wake detection, and Montargez's direct VLT image, all pointing at the exact same object, in the exact same place, doing the exact same thing. That's not one lucky detection. That's three different teams, three different instruments converging on one answer. That's the part astronomers are genuinely excited to dig into next. A star that's basically alone explodes one way. A star with something skimming through its atmosphere, stealing material, stirring things up, that could explode differently. Different debris pattern, different light curve, maybe even a different timeline for when the instability really kicks in. We don't have those answers yet, but for the first time, we're asking the right question instead of guessing at the wrong one. There's actually a chance we already know how this particular subplot ends. Some models suggest the companion itself won't survive long term. It could eventually spiral into Betelgeuse within something like the next 10,000 years, well before the supergiant itself is expected to explode. So this might not even be a permanent arrangement, just a temporary, atmosphere-stirring visitor caught in the act. So the next time you look up and find Orion and pick out that reddish star in his shoulder, remember it's not putting on that slow, strange heartbeat alone. It's got company. A small, bright bracelet orbiting close enough to leave a wake in the atmosphere of one of the biggest stars in the sky. If you like digging into this one, consider subscribing. It helps me keep making videos like this.